And so we continue with congruence. And so we're going to be talking about two triangles being congruent and what determines whether they are congruent or not. Two triangles in the plane are congruent if a sequence of rigid motion can be found that make the vertices of the triangle coincide with the vertices of the other. Okay, so what does this mean? This means that if I have a triangle, I need to have two triangles first off, just like I have below. And so I need to find a sequence of rigid motion. We already know what rigid motions are, right? We have three of them: reflection, translation, and rotation. Those are the ones that preserve the size and shape of an image. So we need the vertices. Vertices, that just means the corners. So in this case, a triangle has three vertices, right? I name it, namely A, B, and C. A quadrilateral has four vertices because it has four corners or four angles. Okay, and the word coincide means to land on top of each other. Okay, so how can I get these three vertices to land on these three vertices? That's what the question is, okay? And if I can do that, then the triangles will be congruent because the size and shape has not been affected, only the orientation. So in this case, it would be a reflection. Notice how B is over here and it used to be over here. Okay, well, the only way I can do this is if I flip triangle ABC and then it becomes into triangle A prime, B prime, C prime. Recall that these marks up here, they tell you how many transformations occurred. Okay, so in this case, only one transformation occurred. Sometimes you'll see two, and that would indicate two transformations occurred. And sometimes you won't see any of the marks, but you will see different letters, and you're going to have to determine how many transformations occurred. So let's look at our first example, okay? In the diagram below, given ADC and BD, remember what this means? Perpendicular. So that means I have a right angle somewhere. So BD is perpendicular to AC and AD is congruent to CD. This means that they're exactly the same, okay? They can lie right on top of each other. They measure the same, they're the same length, okay? So that is given to me. I can use that information. In fact, I should always use that information. So let's start with the given here. BD is perpendicular to AC. Where they intersect is where my right angle is going to be. So here is a right angle, and hey, this also has to be a right angle. Those two angles there have to add up to 180 degrees. They're 90 degrees. Okay. AD is congruent to CD. So I've used this already. Check. AD is congruent to CD. AD is congruent to CD. And I put a mark like that, okay, just to indicate that they are actually congruent. What we need to prove is that triangle BDC is congruent to triangle BDA. So here are few questions to help you navigate that. So the question is, we need to map BDC onto BDA. And what transformation do you think happened here? Because we're always looking for a transformation. Well, in this case, I can tell that this was a reflection over line BD. If I flip triangle ABD over BD, over the line BD, over this line, I will end up on the right side. So A will map to C, and BD are fixed points because they are on the line of reflection. They do not move, okay? So we say it's going to be a reflection over BD. Now we have to prove using rigid motions that triangle BDC is congruent to triangle BDA. Okay, So since a reflection will map triangle BDC onto triangle BDA, and we know that a reflection is a rigid motion, then it has to be true that triangle BDC is congruent to triangle BDA. It satisfies our definition here of triangle congruence. Let's look at another example. In this case, we have that the given is this piece here, and that C is the midpoint of both AD and BE. So what does the word midpoint mean? Okay, these are very important. You always want to look for the vocab in the given. In this case, the vocabulary word is midpoint, and it is right here, C. That means that C is the midpoint of AD. It's the halfway point. So what does that tell us? That tells me that BC is going to be congruent to AC, but it also tells us that it is the midpoint of BE as well. So that means that BC will be congruent to CE. Notice how this time I use 2 marks because I want to indicate the 1 marks are congruent and the 2 marks are congruent. If I put 1 mark only on all of them, then I don't know which 2 pieces are the ones that are congruent. So let's actually use rigid motions to determine why these 2 triangles are congruent. Now you might think that this is a reflection, right? You might think that if I reflect over this point C, that E will map onto A and that D will map onto B. But that's not the case, actually. Look at here at the names of the triangles. A actually maps onto D. Okay, so A maps onto D and B maps onto E. So the only way that I can get B to map onto E is by rotating this. I need to rotate B all the way here, and I'll do the same thing to A. Rotating A will map onto D. So this is actually a rotation. Okay, since a rotation will map triangle ABC onto DEC, and a rotation is a rigid motion, then triangle ABC is congruent to triangle DEC. So here is your check for understanding, okay? I've given you the givens. You need to know what angle bisector means here, okay? So what does the word bisects mean, okay? And recall that we mark angles using an arc, just like that, okay? That's how I would mark an angle. So this is your check for understanding. I'll see you guys tomorrow. Make sure you take notes and that you do answer this check for understanding. This is going to serve as your entrance ticket for the next day.